Hello, my name's Peter van Hardenberg. I'm here to speak with you about our paper PushPin towards production quality peer-to-peer collaborative software. I'm a member of an industrial research lab named Ink and Switch. We are a small research group exploring problems of computing for creators rather than consumers. And the way this manifests and what's brought me here is that one of our tracks of research has been to explore how we can make software that works. We want software that works all the time, uh, that never shows fail whales. We want software that works everywhere, even in Golden Gate Park, as I'm showing here. And we'd like to have software that works forever, which is to say we'd like software that doesn't evaporate when even setting aside sort of like network availability issues, business availability issues, like, if you're working on a PhD and you pick a piece of software, what are the odds that that software will still be available with your notes in it by the end of your program? And, at the end of the day, ultimately, the work that you create, your creative output, is your data, and it should feel like it. Now, we've gathered up a bunch of these principles under sort of a rubric we call local first software. And there's a whole paper you can read about that if you want to get deeper into that. But let's not dwell on that too much today. But the basic idea is that, if your software lives in somebody else's computer and your data lives in somebody else's computer, then you access it, subject to their ability, but also subject to their whims. And it would be nice if instead our most important assets, which is our work, uh, felt more qualitatively and also more sort of quantitatively behaved like it was actually ours. Now, one way to do that, of course, would be to go back to the good old days. If you have one of these boxes under a desk somewhere, you could probably plug it in and fire it up, and it would still work just about the same as it always has. You could use WordStar, you could, Lotus 123 for your spreadsheet, uh, but that's not obviously a great solution for most people today. Uh, it turns out that the last 30 years of software development have brought some benefits, and one of them, among which, in addition to improved user interface experiences, is ubiquitous collaboration and access to our data from every machine. And ultimately, that's sort of the angle that we've explored with the PushPin project, which is how can we have software that will always work everywhere, but where we don't have to give up the benefits of collaboration and sort of data synchronization across our many computers. The result is PushPin. Now, PushPin is sort of the middle child of a series of research projects, beginning with Trellis, which was our very first sort of prototype in this space, and ending so far with Farm, which we have an astute observer will notice we have not talked about publicly or written up. But PushPin is a really nice sort of distillation of a lot of the ideas, and that's why we're talking about it here. So the goal behind PushPin, the sort of technical goals, the manifestation of those philosophical goals, is to create a piece of software with client-only architecture where there's no required network infrastructure, which is cross-platform and fast and uses as much as possible mainstream technology. And what that boiled down to is basically an Electron app written using React, which then builds its application state out of CRDTs that are distributed over a peer-to-peer networking stack, roughly based on the DAT or hypercore technologies in a package we call hypermerge. Now we could get into this in great depth, but I know it's been a long day for everybody, and so I'm just going to really boil down a couple of very high-level takeaways. The first, I think, really significant and interesting result from our work is that functional reactive programming and CRDTs fit together really well. Now, a CRDT converges documents from a bunch of writers into a single reliable state. Functional reactive programming performs a similar task for converging an application state to a user interface state. The idea behind FRP is that you provide a state object to a set of functional transforms that then convert that state object into a user-facing interface. And the interesting engineering challenge here is how to do that in a reliable way so that you don't have to rebuild the whole state every time, and you can diff the previous and new states and sort of just calculate the minimum computation. That's all kind of beyond the interest of, I think, this forum. But the idea is that, if you build software around FRP with CRDTs underneath, then you can make changes in your front end without thinking about the fact that they're being written into a CRDT and distributed to other users, or loaded from other computers of your own, and you'll always get sort of consistent results. I think one of the challenges people have when they try and adopt CRDTs is in fact figuring out, where do I use what CRDT and how do I solve that problem. Well, by using FRP, we sort of say, well, you don't have to solve that problem; it just works. Uh, and it turns out that this model fits really well into sort of existing industry practices and trends. And so React is, at least as of April 2020, one of the largest web frameworks in the world, or most popular web frameworks in the world. And it has a whole host of existing sort of state management systems that this ties really well into. And we have built a number of different prototypes around this. PushPin is built on React hooks today, and manages the state in a way where, from the perspective of an end application developer using sort of the hypermerge pushpin system to build new features, they're just not really aware of other clients. They don't have to think about them. They just build, if you want to build a chat app, you can make an array, you push things into the array, and then they manifest on other computers. And you really don't have to think about it beyond that. And that's pretty cool. The other, I think, important takeaway from our work is that CRDTs uh, paired with peer-to-peer data distribution are a key tactic for building this kind of long-term reliable, ubiquitously reliable, works everywhere software. And that's because, at the end of the day, any service that is centralized is sort of definitionally unavailable when you don't have a good network connection to that service, and that service can cease to exist either because somebody doesn't pay the bill, or because you are simply in a place where you can't reach it. And so, everybody, if I say centralized service, you can imagine like the Facebook API. But in fact, even a lot of ostensibly peer-to-peer systems rely on signaling servers, which are basically brokers that introduce peers to each other. And that's a good example there is WebRTC, which appears peer-to-peer. But in order to actually make a WebRTC peer-to-peer connection to another user, you first have to have a central authority introduce you to each other and broker the connection. And then, another good one is DNS, which there's one global DNS registry. And if you're offline, or if somebody forgets to pay their DNS registrar bill, you don't have access to it. And so you can't, use that then to look up somebody's username or domain name or download a new version of the software. So if you want to have this kind of software that always works, we need to sort of systematically track down and remove all of these centralized services. And the result then is that you end up with this, with no central authority, local peers have to kind of manage on their own. And that's what drives us to adopting CRDTs as sort of a way to tame the complexity of that problem. Now, I will note that although I'm speaking against adoption of centralized services, the cloud is a very useful tool to have in your tool belt, and having nodes present sort of persistently on the network is really important. And even in the Pushpin project, we built something called Pushpin Peer, which runs on an EC2 server or a Raspberry Pi in your closet and can keep your data available even when your laptop is closed and act as an automated backup. And the other thing, which we go into great depth on in the paper, but I will merely refer to here, is that a lot of networks that people use today are in fact quite hostile to peer-to-peer applications because the world has moved so much to a centralized networking environment. There's very little affordance made for supporting peer-to-peer applications, particularly because the existing use cases for peer-to-peer applications are, often somewhat unsavory, such as software piracy. Having, there's a lot more we could get into, but let's leave it at that for now. Keep it short. It's been a long day, I'm sure, for most of you. We have a number of, I think, interesting open problems in this domain that I hope we will continue to look into, and I hope to entice other attendees here to explore. First, and maybe a little bit far afield for this audience, peer-to-peer networking is sort of deeply problematic. There are a bunch of mechanical problems around what's called NAT traversal, network address translation. That's sort of getting through people's routers. But that's maybe less interesting. The decentralized peer discovery model is generally managed something called the distributed hash table, and there's a lot of kind of privacy leakage there, and that's an interesting domain to look at. Getting closer to people's interests here, The user interface concerns, the consequences of building decentralized software are widespread and I think really interesting. So for example, if we have two versions of a document and then I download yours, well, the naive thing to do and what we do in PushPin is just apply all your changes blindly. Of course, that's not really the ideal case. You might want to say, well, I want this change and not that one, or I want to hold your changes or fork my document. There's all kinds of interesting opportunities as well as requirements emerging there. Decentralized documents are going to require decentralized identity and permission systems. If you log into GitHub, Microsoft decides, what you can and can't do, what you can and can't read, what you can and can't write. In a decentralized system, we don't have that. On top of that, we also don't have a single authority saying who is who. And so there's lots of crypto protocols and key management puzzles to figure out here, and there's a lot of interesting work happening in this space. And next, it may be most relevant to CRDT people in the audience. We have a lot of really interesting problems as we are adopting CRDTs at scale in the client. And so for a really simple example of that, we have pretty good performance of our CRDT documents in actually running the application. But there's one really simple use case which is totally crippling to our system performance-wise, and that's the search box. Because in order to search all of the documents in our system, we have to load and replay every document before we can start returning search results. And yeah, we can improve that a little bit by just replaying some of the documents or by storing snapshots, but I think there's a lot of interesting work around sort of like generalizing how we can build federated or distributed indices, and that also ties into sort of the permissions and privacy domain as well. Would love to talk more about any of this. There's obviously a lot more detail in the paper and plenty more work besides we haven't written about. If you want to look at PushPin, you can see it on GitHub. If you want to reach out to me, you can contact me by email or Twitter. And likewise, Martin, thanks so much for listening.